The universe is a vast dark ocean sprinkled with islands of light we call galaxies. Each galaxy is a city of stars, and our own sun is just one citizen among billions in the Milky Way. When we look up at the night sky, we're actually staring into the deep past, seeing light that has travelled for years, centuries, even millennia just to reach our eyes. This cosmic ocean is filled with wonders that really challenge our imagination: exploding stars, swirling nebulae of gas and dust, and planets of ice and fire. It's a place of incredible beauty and profound mystery, inviting us to explore, to question, and to discover our place within it all. Among all the strange and beautiful objects out there, some are so bizarre, so extreme that they honestly seem to belong in a science fiction story. These are not monsters, but they are monstrously powerful. They are not empty, but they are the definition of emptiness. They are the ghosts of the cosmos, objects that we cannot see directly, but whose presence we can feel across vast distances of space. We are talking about the universe's ultimate enigma, a place where the familiar rules of physics break down and reality itself is stretched to its limits. These cosmic phantoms are what we call black holes, the main topic. Imagine a waterfall so powerful that once you cross its edge, no boat, no matter how strong its engine, could ever escape its pull. This is the kind of power we are dealing with, but instead of water, it's gravity. The universe is full of these gravitational waterfalls, these one-way doors to an unknown destination. They are a fundamental part of the cosmic story, shaping the galaxies they live in and holding secrets about the very fabric of space-time. Our journey to understand them is a journey into the heart of the universe's most mind-bending concepts. A true adventure for the human mind. Embarking on this cosmic adventure requires a sense of wonder, the same feeling a child has when they first see the ocean or look at the stars through a telescope. It's a feeling that reminds us that there is so much more to the universe than what we experience in our daily lives. We are part of something immense, something ancient, and something that is still unfolding. By studying these extreme phenomena, we are not just learning about distant objects. We are learning about the fundamental laws that govern everything, including ourselves. The quest to understand black holes is a quest to understand the universe itself. So what exactly is a black hole? The simplest way to think about it is as an object with an incredibly strong gravitational pull. Imagine you're playing catch on Earth. You throw a ball up and gravity pulls it back down. If you could throw it fast enough, about 11 kilometers per second or 25,000 miles per hour, it would escape Earth's gravity and fly off into space. That speed is called the escape velocity. A black hole is an object whose escape velocity is faster than the speed of light, the fastest thing in the universe. Nothing, not even a beam of light, can travel fast enough to escape its grasp. Because not even light can get away, we can't see a black hole directly. It's like a perfect trapdoor in the fabric of space. Anything that gets too close falls in and can never come out. The black part of its name comes from the fact that it absorbs all the light that hits it, reflecting nothing. The whole part is a bit misleading because it's not empty. A black hole is actually an enormous amount of matter, the stuff that makes up stars and planets, crushed into an unbelievably tiny space. This super-dense matter is what gives the black hole its mind-bogglingly powerful gravity. The border around a black hole, the point of no return, is called the event horizon. Think of it as the edge of that cosmic waterfall we talked about. Once you cross the event horizon, you're caught in the black hole's pull forever. There's no turning back. From outside the event horizon, you would never see your friend fall in. Instead, as they got closer to the edge, they would appear to slow down and fade away, stretched and distorted by the extreme gravity. It's a place where our everyday understanding of time and space simply ceases to apply in any familiar way. At the very center of a black hole, theory tells us there is something called a singularity. This is the point where all the matter that has fallen into the black hole is crushed down to an infinitely small, infinitely dense point. Here, the laws of physics as we know them, the rules that describe gravity, time and space, completely break down. We don't yet have the science to understand what a singularity truly is. It represents the edge of our knowledge, a place where our two best theories of the universe, general relativity and quantum mechanics, have yet to be reconciled. Black holes aren't just born out of nothing, they are the dramatic final act in the life of the most massive stars in the universe. Most stars, like our Sun, will live relatively quiet lives and fade away gently, but stars that are much, much bigger than our Sun, we're talking at least 20 times more massive, have a far more spectacular destiny. These stellar titans burn through their fuel at a furious rate, shining brilliantly for millions of years. They are the rock stars of the cosmos, living fast and dying young in a blaze of glory that can outshine an entire galaxy. Throughout its life, a massive star is in a constant battle with itself. The nuclear fusion in its core creates a tremendous outward pressure, pushing everything away. At the same time, the star's own immense gravity is trying to crush everything inward. For millions of years, these two forces are in perfect balance, but eventually the star runs out of fuel for its nuclear furnace. When the fusion stops, the outward pressure suddenly vanishes. With nothing to hold it up, gravity wins the battle in a catastrophic way. The star's core collapses in on itself in a fraction of a second. This sudden, violent collapse triggers a massive explosion called a supernova. The star's outer layers are blasted out into space with incredible force, creating a beautiful, expanding cloud of gas and dust that will one day form new stars and planets. But the core, the heart of the star, keeps collapsing. If the core is massive enough, there is no force in the universe strong enough to stop its collapse. It just keeps getting smaller, denser, and more powerful, crushing itself down past the point of no return, until it becomes that infinitely dense point, a singularity. A black hole is born. There is another, even more colossal type of black hole. These are the supermassive black holes, and they are millions or even billions of times more massive than our Sun. We find these giants lurking in the centers of nearly every large galaxy, including our own Milky Way, where a behemoth named Sagittarius A** resides. We aren't entirely sure how these monsters formed. Perhaps they started as smaller black holes that grew over cosmic time by swallowing stars, gas, and even other black holes. Or maybe they formed from the direct collapse of gigantic clouds of gas in the early universe. You might think that with their all-consuming gravity, black holes are purely destructive forces, but the universe is more complex than that. It turns out these gravitational giants are also cosmic architects, playing a crucial role in building the universe as we see it. The supermassive black holes at the centers of galaxies, for example, act as gravitational anchors. Their immense pull helps to hold the galaxy's stars together in their orbits, shaping the structure and evolution of the entire galactic city. They are the unseen rulers of their starry kingdoms. We can't see black holes, but we know they're there because we can see their effects on the space and matter around them. We can watch stars orbiting an invisible point in space, moving at incredible speeds. We can detect powerful jets of energy and radiation being shot out from the regions near a black hole as it feeds on nearby gas and dust. Recently, scientists with the Event Horizon Telescope even managed to take a picture, not of the black hole itself, but of its shadow, the dark region at its center, silhouetted against the glowing, superheated material swirling around the event horizon. This image of the black hole in the M87 galaxy was a monumental achievement, a testament to human ingenuity and our relentless curiosity. It confirmed predictions made by Albert Einstein's theory of general relativity over a century ago. It showed us that these bizarre objects are not just theoretical concepts, they are real physical parts of our cosmos. Discoveries like this give us confidence that we are on the right track, but they also open up a whole new set of questions that push the boundaries of what we know about the universe. And so, our cosmic adventure continues. What really happens inside the event horizon? What is a singularity made of? Do black holes eventually evaporate over trillions of years, as Stephen Hawking predicted? Are they gateways to other universes, as some science fiction stories imagine? We don't have the answers yet. Black holes remain one of the greatest mysteries in all of science, a dark and tantalizing puzzle waiting to be solved. They remind us that the universe is not only stranger than we imagine, it is stranger than we can imagine.